Today we're starting a brand new unit. This unit is called Trigonometry of the Right Triangle. Today we're going to examine basic trig ratios, and it is May 4th. The note packet you'll need today has 4 pages. Before we get started with the actual ratios, when you do trigonometry, it's very important that your calculator is in degree mode. So really for us, that'll be our iPad. So the easiest way to tell is to use a calculator screen, which is gray. If your calculator is in degree mode, you're going to see it in the left-hand side. It will say DEG. If it's like that, you're all set. You don't need to do anything else. If it says RAD, that means you're in radian mode, and we need to make a conversion. So if yours says radian mode, what you want to do is find this gear up in the right corner, select the gear, and you're going to get this white screen about document settings. On the document settings, you're going to look for angle, and you're going to change this to degree. So you'll have to select the arrow. When it says degree, go down to the bottom and select Make Default. This will keep this in degree mode permanently until it resets itself, but it should be a while. So now that we're in degree mode, you should know that the word trigonometry comes from the Greek, and it means triangle measurement. All the trig ratios that we're going to work with all deal with a right triangle. So trigonometry sounds fancy and it sounds difficult, but it's very simple. It's really just a set of ratios, which means they're fractions, and it will help us describe the triangle's relationship between the sides and the angles located between those sides. You can see in my diagram, we use the Greek letter theta, TH, theta, to describe a missing angle measurement in trigonometry. Just to review, on our right triangles, we know we have 2 different components. The first is the hypotenuse. The hypotenuse is the longest side of the right triangle, and it's always found across from the right angle. So if this is my right triangle, the right angle might be here in the bottom left corner. The hypotenuse is always across from that. That will never change. The other 2 sides, normally we call legs when we work with Pythagorean theorem. In trigonometry, the legs refer to the side opposite an angle or adjacent to the angle. And that angle depends on which one I'm working with. So in the picture, there's an angle here highlighted in yellow, but there's also an angle up at the top. So the opposite and adjacent sides will change and they will move. So let's get an idea of the orientation for the opposite and the adjacent sides of your right triangle. And again, these will move. So here's scenario 1. I see my right angle at C. The hypotenuse is always directly across. That will not change. I'm working here at A. I put a little star here. Think about this when you're in a big mall. The star represents you are here. So if I'm working with angle A, directly across from me would be my opposite side because they're across from each other. The side between C and A is called the adjacent side because it's touching the angle. Adjacent sides are next to each other. However, if I move to a different angle, the scenario changes. So now we have scenario 2. My right angle at C is always directly across from the hypotenuse. That will not change. But now if I'm working at B, the side directly across from me or opposite is now CA, and the side adjacent or next to is side BC. So the opposite and adjacent will change when you move to a different angle. The first trig ratio is called the sine ratio. We abbreviate sine as SIN. We do not call it sin, it's still sine. This ratio always compares the length of the opposite side to the length of the hypotenuse. The second ratio is called the cosine ratio. We do abbreviate it as COS. We still call it cosine. The cosine ratio always compares the adjacent side to the hypotenuse. And the third ratio is called the tangent ratio. We abbreviate it as TAN, and we're always comparing the opposite side to the adjacent side. Now we need to remember which sides go with which ratio. So we have a phrase. The phrase says, some old hobo caught another hobo tripping on acid. How is this going to help you? Here's how it helps. The first letter in each word represents the ratio and the two sides that it compares. So the phrase some old hobo, the S, O, and H represents the ratio of sine, and it's the opposite side to the hypotenuse. Opposite side is always the numerator, hypotenuse is always the denominator. The next part, caught another hobo. That represents the cosine ratio, C, and the comparison is the adjacent to the hypotenuse. The last part, tripping on acid, is the tangent ratio, and it's always opposite side over adjacent. So if you can remember this phrase, you'll have the setup for sine, cosine, and tangent. So for our first example, we're going to express the ratio in simplest form. We're not going to convert it to a decimal. These are better left as fractions. You'll notice that in all three of these examples, we're using x. That means you are here at angle x. Because I'm working with angle x, that means across from it, 3 is my opposite side, and 4 is next to it. This is my adjacent side. And there's my right angle, so 5 is always my hypotenuse. So if you're here at sine, this is some old hobo. Opposite over hypotenuse. So the ratio is 3 over 5. For cosine, caught another hobo. Adjacent over hypotenuse. 4 is my adjacent, 5 is my hypotenuse. So adjacent over hypotenuse is 4 over 5. Tangent is tripping on acid, opposite over adjacent. So the tangent ratio is 3 over 4. We're going to use the same triangle, but we're now going to move to angle Z. You can see I marked it with the star. You are here. Because I'm now here, 3 is the side next to the angle, so this is my adjacent side, and 4 is opposite, but 5 will continue to be my hypotenuse. So sine, some old hobo, opposite over hypotenuse. The ratio is 4 to 5. Cosine, caught another hobo, adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5. The ratio is 3 to 5. In tangent, tripping on acid, opposite over adjacent. Opposite is 4, adjacent is 3, the ratio is 4 over 3. In our next example, we have different numbers for triangle MNO. Notice in the example, we're using angle N, so you are here. We're going to classify our sides then based on our location. So 10 is opposite, 24 is adjacent, and with the right angle, 26 is my hypotenuse. So if you're here at N and the sine ratio is some old hobo, the ratio is 10 over 26. Now, if you can reduce the ratio, you must reduce the ratio. So both of these reduce to 5/13. Cosine, caught another hobo. Adjacent over hypotenuse. Adjacent is 24, hypotenuse is 26. And that reduces to 12/13. Tangent, tripping on acid, opposite over adjacent, 10/24, and it will reduce to 5/12. We're going to switch our location. We're now located in angle O. So we're going to go through. 24 is now opposite, and 10 is now adjacent. So sine, opposite over hypotenuse. 24/26. Oh, and it looks like I messed that up. 24/26. This is 12/13. Cosine is caught another hobo, adjacent over hypotenuse. It should be 10/26. And the last one, tangent, opposite over adjacent. 24/10 reduces to 12/5. So the three trig ratios, sine, cosine, and tangent, just compare the side lengths of the triangle to the angle in between. We're going to leave them as reduced fractions. Your homework that goes with this assignment is 116. It will say basic trig functions. I believe that it is two-sided, so make sure you flip it over and see that there's a back. If you have any trouble going through this assignment or there's something in the notes that you don't understand, please make sure you contact me. Otherwise, have a great day.